I think we can continue now, maybe with the next part, and we'll introduce a few other things about the course and then get into some hands-on Python stuff. So as noted here, we're continuing on the course website. And if you want to follow along, you can go there, or you can just watch the screen for the moment. But each week we have a lesson overview. And normally what happens in the lesson overview is there'll be a list of things like our learning goals. So for this week, we're going to kind of learn about what tools we use in the course, some of the basic concepts of computer program and programming language. Well, we just saw that. But then we'll get some hands-on experience with Python to learn how to define and use variables, understand the concept of a data type, and how to determine a data type in Python. So that's what's coming up still in today's lesson. Oftentimes there will be a link to the different lesson parts here, but it's also over on the left side that you can find the other parts of the lesson for each week. So the first thing for us to take a look at today is about our course environment. And this might be a little bit confusing at first, but each one of the things that we use in the course we use for a good reason. And you'll get familiar with it after the first week or two in the course. You should hopefully understand kind of how everything is working. And so, yeah, we'll just go through some of these course environment pieces here first before we get into our first bit of Python coding. And so if you look at the course webpage, there's a couple things I want to point out about the webpage itself. One is that there is this option to have interactive code cells. So there is this little button you can click on the course page to basically make certain parts of the course interactive so that you can actually do some coding on the web page itself. When that's available, when it's possible, you'll see this icon show up. It looks like a little space shuttle, and you can click on the button Live Code to launch this thing called Deeb. So just to demonstrate in our Taste of Python lesson, if you go to that page, what you'll see is that there would be the possibility to click the live code button here, which would then make it so that there are parts of the web page you can interact with. I'm not going to demonstrate that further because we don't really use it much, but just to note that it is there. It's still somewhat experimental. Sometimes it doesn't work as expected, so we don't often use it, but it is possible that if you just want to see something and test it out quickly, you can do it directly from the course webpage. But for most of our programming, we're going to be using a web-based coding application called Jupyter Lab. And there's different pieces that are part of Jupyter Lab, but it's one of the kind of core things that people in data science are using these days. And if you look at the Jupyter Lab application, which we'll do shortly, you'll see there's things like a file browser. There's ways to actually write code and interact with the code. And it's built around the idea of a document called Jupyter Notebook, which has this IPYNB file extension for the type of file that it is. And a Jupyter Notebook is basically a document where you can have boxes that contain code, and you can have boxes that contain what we call rich text elements. So this could be figures, it could be links, it could be just formatted text. And they're really nice for things like data science and actually for learning to program as well, because you can have places where you can describe what you're doing, and then you can have a little piece of code that does something. And so you can kind of have your documentation and your program together in one place. So this is the basic default thing that we're going to be using in the course. But in order to use Jupyter Lab, you need to run it on some kind of server. That server could be your own computer, or it could be one of a number of different cloud computing environments that we offer. And those are what we described here a little bit below. And we'll get into using Jupyter Lab, so we don't need to look at the kind of figures that are on here for right now. But as far as our cloud computing environments go, you'll see there's multiple ways in which you can open up some of the documents. Like, again, if you go to this Taste of Python lesson, you'll see there's a possibility that you could open this in a free cloud computing environment called Binder, or you can open it with this thing called the CSC Notebooks, which is actually what we'll recommend doing. We'll demonstrate how to do that in just a moment. But the cloud computing environments are sort of temporary things. The idea of the cloud is that you can create a computing environment and throw it away just as easily. And so when you use things like Binder, there's no file storage that's available to you there. So that's something to be aware of. We'll mostly recommend that you use CSC notebooks, although for this week's exercise, you're welcome to use Binder as well. But it's basically just a web interface to allow you to open up Jupyter notebooks to run inside your web browser without having to do any kind of software installation or anything like that. So we have links to open up our exercises and to open up our lesson notebooks in Binder. You can just click the button, it takes a moment or two, and it pops up, and you can then start interacting with it. The key thing with Binder is that you have to remember to save your work because it is temporary and all your files will be lost after your session is finished. And unfortunately with Binder, that session will be automatically completed for you if you're inactive for more than 10 minutes in Binder. It basically will disconnect you from the server and you may lose your data as a result. That's part of the reason why we don't suggest using it. The other part is that sometimes Binder is having technical issues. It is a free service, so you're kind of subject to when it's working and when it's not. Sometimes there's problems, and often seems to be at the time when you don't want there to be a problem that there's a problem with Binder. So instead, we recommend that you use this notebooks platform by the CSC, which is this Finnish IT Center for Science. And it is very similar in many ways to what Binder is doing in the sense that it opens up a Jupyter notebook on the server. But there's a couple important differences. One is that when you open up one of the notebooks instances, it will be alive for 8 hours. So you have 8 hours that you can use it. If you take a break and go have lunch or something like that and come back, you can still see that your environment is alive. In addition, it does offer some persistent storage, meaning that you could save files in the CSC Notebooks platform. And so if you, for some reason, your instance dies because you've run out of the 8 hours, your files will still be there and able to be used from where you left off. So that's a good thing. Now for us, the next step is to actually check out this CSC Notebooks platform. And we're going to do that now in the class. So if you have a laptop with you, I guess you could also do this on a phone, but it might be a little bit frustrating. Otherwise, you can do this the next time you have access to a computer. But if you've got a laptop with you, I'd like you to go to this notebooks.csc.fi website, which I will now switch over to myself. So when you go to the CSC Notebooks page, you get redirected to a page that looks like this. And the first step here is to click the login button. Once you've clicked login, you're going to be asked for these different options, and what you want to use for your login is this Haka option. For the first time you click it, most probably you'll be prompted to ask you which university you're affiliated with or which educational institution you're affiliated with, and you should choose the University of Helsinki. When I click it, I've already done that, and it's probably in some cookie that I've already made that choice. So when I click Haka, it automatically takes me to actually log in through the university's website. But you should click login, select Haka, and then choose University of Helsinki for your authentication, and then you can log in just with your normal university credentials. So I'll just type in my username and password. And your view may look a little bit different than mine when you log in, but it should look something like this. Maybe I will ask if Kamyar can just let me know if people are stuck or behind or anything like that. But you should hopefully be able to get to the point where you have logged into the CSC Notebook platform. You probably won't see Geo-Python 22 or 23, but don't worry about that. We're going to cover that in just a second. So at this point, in order to see the Geo-Python 2023 instance, this is basically our cloud computing environment that we'll be using in the course. You're going to have to click this Join Workspace button up here on the top. And back here, as basically we're just following the instructions here, you'll see that there is this join code that you need to copy and paste into the place. So when you click Join Workspace, it asks you for a join code, and you just paste that in there. And then you can click the plus button, and it should then join you into the Geo-Python 2023 organization workspace, I guess. I've already done that, so it tells me that I'm already a member of the Geo-Python 2023. Again, if you're having any trouble, don't panic. You can follow the instructions for this also based on the course webpage, and it will be similarly easy to follow to do this again if you are having any trouble or don't have your computer or whatever. Now, once you've joined, you should see this Geo-Python 2023 thing here, and there's a little power button, and you can click that to start your first session of the Geo-Python 2023 notebooks environment. Depending on how many people click that at the same time, it may take a second to launch, but it should launch. And at least I'm getting a message it's trying to find free resources, so maybe lots of people have clicked this at once. But if all has gone well, you should end up on a page that looks like this. And I'm just going to quickly log in on my other iPad here with the administrator view so I can see how many people have joined. Looks like there's 42 people now, so that's a good thing. And I probably somewhere can also tell how many people are running an instance right now, but I don't immediately see it. No, I see it. Okay. So it looks like at least 38 people are up and running, still some launching, so that's good. Yeah, let's then continue like this. If you're having problems, maybe let Kamyar or if there's any of the course assistants still around, let them know, but we'll continue from here. So we're now in the CSC Notebooks platform. We're now in Jupyter Lab, and things are looking pretty good. We got a couple steps, and then we'll be all set for looking at today's lesson. So when you launch the Geo-Python 2023 workspace the first time, we need to go and do some extra steps. So first, we need to double click on the My Work folder. So let's go back over here. You should see Shared and My Work as two folders that you can view. And if you double click on My Work, it should be empty. And that's what you should do first, is just double click on My Work. Then we're going to click on this little icon over here that says Git. We'll use this more later on in the course, and we'll talk about this in more detail next week. But for the moment, we'll just click on that. and then click on Clone a repository. To the bottom option of the three, and then it says, okay, well, what's the URI of the remote Git repository? And for that, what you want to type in is, or you can copy paste it if you want. If you've got another tab open with the course page, it's probably easier to copy paste. But you could also type in github.com/geo-python/notebooks.git. Just to show you, I'm just typing in this thing here that's like after launching the first time. So you type that in, and then you can hit clone. Should have permissions for that one. And you should see then after that that there's a folder inside my work called Notebooks. Let's leave it like that for right now. We could double click if you want to see what's in there. There's an L1 folder in here for lesson 1, and we're going to open up one of these notebooks in just a second, but let's go back to the course environment for just a moment. And we'll show a few other things here just because it might be helpful if any questions come up. So again, we just went through this steps for connecting to the CSC notebooks the first time, and then launching Geo-Python 2023 for the first time, what to do. And we'll actually do this step next lesson. So whenever we open up our CSC notebooks in the beginning of each lesson, we'll go through this step where we get the latest changes, but we don't need to do that right now because we've already got the latest changes. In case you want to install Python on your own computer, there's some instructions here about how to do that as well. We'll talk more about Git and GitHub in detail next week, but basically these are kind of one of the pieces that's important for making our software reproducible, and that is that we're using this software called Git, which is a version control software, which means it basically can be used to store versions of the software that you're writing, versions of Jupyter Notebooks, for example, and keep track of the changes that have been made. As mentioned, when you have things like you have code that used to work and then you broke it, Git can be one of these things that can save you in the sense that you can go back and see what the code looked like when it worked last time. And notably, it was developed by a rather famous Finn, Linus Torvalds, who also was the developer of Linux. And at least we're at the Chemicum this year, but in previous years, we've even been in the Linus Torvalds auditorium in the Exactum. He's a pretty famous guy. So we'll talk about Git a little bit more next week, how it operates. I'll leave it kind of brief for now just because I want to have some time to actually do some other stuff before we run out of time in today's lesson. But we'll also be using GitHub. We've already just actually pulled down our notebooks from GitHub, but it's a web page that allows you to share software that's using this Git version control system. But not only can you share it, there's a sort of social network built in there, so it makes it easy to kind of collaborate on software projects. So, for instance, for those teachers in the course, we're using GitHub basically to share all of our teaching materials, the course webpage, all the exercises and things like that, so that all of the teachers can contribute to the development of the course. But yeah, more about that next week. We'll talk really about how Git works then, because we don't quite need to know it just yet. As you've already seen, the voting and polling, we have these Pressimo polls, and you'll be asked from time to time to go to this webpage to vote. That's only active during the lesson, so for anyone who's like missed the lesson and then came to watch the video, the polls are not going to be active. And then we have this sort of online discussion, like instant messaging chat software called Discord that we use. And I'll also just show you now Discord. I think a lot of you have gotten my email and have maybe, as a result, already joined the Discord. So I could see lots of people who have been signing into Discord, which is great to see. And yeah, it's basically a place where instead of sending emails to myself or Kamyar or the course assistants, we would ask that most, if not all, of the course-related communication happen on Discord. And that can mean like in some of these places, um, like the general channel is a good place to say, hi everyone, type in some message just to greet people. And when someone has posted something, if you like, you can add reactions to it, um, whatever they might be. And you can see more people now joining Discord from the email link. The course page has this kind of general thing here, but there's more about Discord actually in this communicating with Discord part of the course page here. So that's where all our discussion, question and answers about the exercises, all that stuff happens there. And we sent out over email the join code for Discord because it's meant to be only for the people who are registered in the course or who plan to register for the course. So if you haven't received it, we'll make sure that you can join the Discord. It just might be that you have to send an email to myself, and perhaps maybe it's good if you send it to Kamyar and I to let us know that you need the Discord join code for students at the University of Helsinki or Aalto who are enrolled in the course currently. Just to make this clear, the reason I say this is that we also share everything on the course page online, and there are plenty of people who do the course outside of the enrollment time, but we don't support people via Discord other than the time when we're running the course for the enrolled students. But yeah, there's a kind of overview of Discord here about how it works. Basically, there's discussions that are grouped into different topics called channels. So if we look in Discord now, you'll see there are these different channels here. You'll see there's like week 1, week 2, week 3, week 4, whatever. There's also an enrollment issues channel and a random channel. And then there's some like you won't see like the instructors channel, but there's these are all these different kind of places where you can communicate about things. And if you have questions or if you want to say something about week 1's exercise or lesson, it's best if you put that into the week 1 channel. It's easy to search. It's easy to tag people with the @ character. So like inside the general channel here, I could, for instance, say, hi to Kamyar and hope all is well in the chemical or whatever. That would then, give the person who I have tagged a little notification that they've been tagged in a post. So like if you're trying to get the attention of your course assistant or one of the instructors, you can of course tag us that way. And you can also use threads for some of the conversations. So sometimes like if somebody asks a question, you can basically go into one of the posts, hover over it, and click this little like hashtag sort of number sign icon to make a thread, which allows you to then have like follow-ups specific to that one post here. And I could say it looks nice outside here, but it will be hot today. And at least hot for me, it's going to be 30 or something like that. So anyway, now this has become a thread where I could sort of follow up on the discussion and keep it organized with comments related to that specific post or that first thing that was put in here. So you'll see some kind of overview of how this works, basic usage of Discord and how to navigate. That's in here. You've seen now how to use the @ symbol to notify a user and also how to use threads. Threads are great. Like if somebody asks a question about a certain part of an exercise or a certain part of a lesson, that the comments that are related to that could be made into a thread to follow up, just so that if somebody else is curious, they click on the one post and they see all the thread comments that are there. So you'll see there's some additional instructions about the course page there. And yeah, if you're having issues with things, this is kind of the best place to be active in communication. Couple guidelines about the communication, though. Please do select the right channel for your question. So if you have a question about week 2, put it in the week 2 channel. If you want to just share something silly, some programming GIF you found or whatever, the random channel is a good place for that kind of stuff. It's entertaining, so please feel free to, put some fun things into the random channel as long as they're appropriate for the group. Use threads to keep the topics kind of grouped together in a way that it's easy to find information and follow what's been discussed. And just be active in Discord. Like if you have questions, please ask in there. The instructors and course assistants, we monitor this, but also the other students in the course look at it and they may have an answer before any of us can get back to you about things like, is there a typo in this part of the exercise or blah, blah, blah. So you could definitely ask questions in Discord and get quick responses, hopefully that way. And if you see somebody post something and you know the answer, please do feel free to look at it and comment. Every year we have a handful of students who are quite active in this. We've used Slack in the past, but it's more or less the same kind of idea as what we do in Discord. And there's lots of active people there discussing things, which is really great. One caveat is please don't provide ready answers in the discussion. All right. So don't just if somebody asks a question about the exercise, please don't just copy paste in the code that is the solution to that part, because that doesn't really help them to learn. So instead, try to give back a response that helps guide people in the right direction rather than giving them the answer. So yeah, that's the kind of overview of Discord. And again, I see back in the general channel that quite a lot of people are already here. 21 people online right now, so that's great. And there's 16 who aren't. So a lot of people, it seems, have already found their way to Discord. So please, let's feel free to use this. In fact, in this week's exercise, you'll get a chance to have your first opportunity to play with things in Discord. But now, let's go back to our CSC Notebooks environment. And we can continue with our first little, wading into doing things in Python. You go over here on the left side in the Notebooks folder, in the L1 subdirectory, there's a taste of Python notebook. And if you double click on that, it opens up and it should look like this. And this is our Jupyter notebook we're going to use for the rest of today's lesson, other than the preview of today's exercise. There's a little bit of information that describes what a Jupyter notebook is. We've gone through some of this, but as a reminder, you can read through there if you want more. And I think we already have this open, so we don't need to worry about this other stuff about how to get Jupyter Lab started. But yeah, in here, with the first part, we'll just look at variables, math, and some functions. And to get us started, if you're in Jupyter Lab in this environment, you can click on the top cell, and we could do some very simple math, like we could do 1 + 1. And you type in 1 + 1, nothing happens. But if you press Shift and then Enter, it will run that cell, and you see 1 + 1, and the answer that comes back is 2. Likewise, if we type in 5 × 7, you can either press Shift Enter again, or if you're a kind of mouse or trackpad oriented person, you could also go up to the top and click the little play button up here, which does the same thing as pressing Shift Enter. I'm kind of keyboard oriented, so I never do that. But if you like to click on things, you can also run cells that way. And you see 5 × 7 = 35. So that all looks good and more or less as we might expect. You can close this little thing if you find it annoying. So of course, yeah, we can do simple math, adding, multiplying, no problem. How about functions? Of course, we can do more advanced math with Python as well, like calculating sine or square root. So if we do, for instance, the sine of 3, by just typing sin and then parentheses 3, and if you run this one, you'll see an error message. If you do the same thing with the square root, let's say square root of 4, and you run this, you'll see an error message. And the issue here is not that Python can't do this calculation. Of course, calculating the sine of 3 or the square root of 4 is something that's well within the scope of what you can do in Python. However, in order to do that, we need to extend the basic set of functions that are available to Python by loading in a different library. So by default, with Python, if you try to do the sine or square root function, what you do is you get a name error and it says like sqrt is not defined. It means I don't have anything called sqrt that I know about to do any kind of calculation with. There's no function called sqrt available. We'll come back to this in just a second. The default available options in Python as far as math goes are addition, subtraction, multiplication, division, and exponentiation. And those would be equivalent to basically plus minus, multiplying, dividing, and then raising something to a power. And you can see some examples here. That's what you could do with math by default. If you want to do something more involving math, then you need to tell it we're going to use the math library. And you do that by typing import and then math. So import is the way in which you tell Python to read in a library and make it available to do things like calculations with that library. So when I type import math and hit shift enter, I see no output. But what I can see is I get the number that shows up here inside the brackets, which means that this cell has been run. And now, if I wanted to do something like calculate the sine of 3 or calculate the square root of 4, I can do it by doing math.sine of 3. This indicates that the math library is being used, and from the math library, we're using the function called sine to calculate the sine of 3. I don't know, that looks about right. 0.14. Sine of pi would be around 0, so that's, yeah, looks about right to me. Math.square root, so sqrt of 4. And now when you run this, you see that the square root of 4 is 2. Okay, this looks like it's working properly. So it's not that Python couldn't do this, we just have to extend what's available. By default, what we start with is pretty basic in terms of the options that are available for doing things like math calculations. So what we've done basically is we've just taken a library, also known as a module in Python, and read it in using the import statement. So that allowed us to read in, for instance, the math library and make those functions in the math library available. Then to use them, we said math dot and then some function name to be able to do things like calculate the sine of 3 or the square root of 4. And that sort of syntax, that's how you do that with Python, is the library name dot function name, module name dot function name. And within a notebook, things that you defined earlier will be available in later cells as long as you've executed them. So like we've run the import math, so now any place in this notebook that I want to use the math library, it should still be available to us. One other thing to note here is that there are things like math.py. So without any parentheses there, I'm indicating that I don't want to use a function, which would normally have parentheses after the name of it. But instead, I just want to refer to a value or what's called an attribute in Python. So there are things like math.py that is actually used as like a way to store the constant of the value of pi. So math.py, when you run that cell, you see you get 3.141592, whatever. The bunch of digits of pi, maybe 16 digits of pi. So those values are also available in some of these libraries, like these kind of constants. So then let's take a chance and let you do something now. And that is with this empty cell that we have here, why don't you use that cell to calculate the sine of the value of pi? And then after you've done that, you can think, what's your expectation here? Did you get the result you expected? So take a couple of moments and maybe come here, maybe you can let me know when it seems like people are ready and we can continue after that. So what I can do is I can maybe show an example so that if you were still working on this or unable to do it, you can see what we were looking for. But sine function, again, would be math.sine. And then we would put our parentheses of what we want to calculate the sine of. And in this case, we want to do math.pi as the value we want to calculate the sine of. So math.sine, parentheses, and then inside the parentheses, math.pi. And when you run this, you get some number that's 1.22 and so on times 10 to the minus 16. So very close to 0. The sine of pi should be exactly 0, but computers can represent things like the number pi with only so many digits of precision. So that means that when you calculate the sine, sometimes you get a number that's not exactly 0, but very close to 0. So if we rounded this off to even 14 decimal places, it would be 0 for the value. So obviously we're quite close to 0 with that one. So that's how we can calculate the sine of pi, for example. Now we can also combine functions. So we could use the function called print, which we haven't seen yet, but it just displays things to the screen. So we could, for instance, say print out the square root of 4, which is math.sqrt of 4. So this is a function that's calculating a value here. And then we're using another function to print out the value that's being calculated. And it's totally fine to do things like this. So when you run this, you get back out, well, basically the same output that you got before, which might lead you to say, like, well, why would you even bother with doing that? But the difference would be that you could do something like print and then have some text, like 2 plus 2 is, and then something you calculate, like 2 plus 2. So here I'm going to add some text. Note that I'm going to put the text in quotation marks. It could be single quotes or double quotes. Double quotation marks is more common in Python, but they work functionally the same way. So I have 2 plus 2 is in quotation marks, and then a comma, and then my value I'm going to calculate, which is 2 plus 2. And when I run that, I see 2 plus 2 is 4. So that looks good. We could also, for instance, combine our print function with the square root function to say, for instance, the square root of 4 is 2. So we could again say print, and then in quotation marks, the square root of 4 is, and then math.sqrt of 4. So again, the text is in quotation marks, comma, and then here, where I'm calculating the square root of 4, I have parentheses and then a value in between the parentheses. And just note, you have to pay attention that your parentheses are balanced here because you have a square root function and the print function, so there's 2 closed parentheses. But when I do that, I get the square root of 4 is 2, just like we would expect. Maybe I'll leave that visible for the moment. Now, so far what we've been doing is just calculating things and having it displayed to the screen, but we can also use a variable or muuttuja that we can use as a place to basically store a value that we calculate. It's quite simple in terms of how you do it. It's just variable name equals whatever the value is that you want to store. And then from that point on, you can refer to that variable to get that value. So for instance, if we defined a variable here called temp Celsius, so temp underscore Celsius, and give it a value of 10, I would just do that as so. The temp Celsius equals 10.0. And if I wanted to then print out the value of temp underscore Celsius, just to see that everything worked, I could use the print function and then print temp underscore Celsius So when I run this, it's going to first store the value and then print it out. And we can see indeed that the value of temp Celsius is 10.0. Now, we can also even go a step further with this, and that is to add in a bit of math in our calculation of something that would be printed out to the screen using a variable value. So, for instance, we could say print, and then we could say temperature in Fahrenheit. And you could just say temperature in F if you want to avoid typing in Fahrenheit. And then after our comma, we can put in a conversion to change our temperature in Celsius into Fahrenheit. So we would do this as 9 divided by 5 times temp Celsius plus 32. So this then is our conversion. We're now doing some math with our value for temp Celsius. Remember, that's just equal to 10. We're going to do 9 over 5 times that value plus 32 to convert our temperature into Fahrenheit. And then we'll print this out to the screen. So when I run this, then I get temperature in Fahrenheit is 50 degrees. And that sort of makes sense. That if we were to take 9 times 10, that's going to give us 90, divided by 5 is going to give us 18, plus 32 is going to give us then 50. So it seems to check out in terms of our temperature conversion. Now we have a chance for you, again, to test yourselves out. And what you can do is you can use the empty cell below, and you can define a variable value, it doesn't matter what it is, and print it to the screen using the print function. So anything you like. If you want to define a couple variables, that's fine. But you can just take a moment and define a variable and print it to the screen, and we'll continue in just 1 or 2 minutes. So hopefully you've been able to define some variables, or a variable at least, and print it to the screen. We could, for instance, do one here just as fun, where we could say part 1 equals I like, and part 2 equals Python with an exclamation mark. So we define 2 variables, and then we could print part 1, comma, part 2. So part 1 is I like, part 2 is Python. When you have a comma like this, it's going to automatically put a space in between the 2 things there. And as a result, we get I like Python as a single string printed to the screen. Of course, you could do an infinite number of things with this little example case here, but that's the general situation. Now, we can, with our variables, they are things that can be updated. So temp Celsius was 10 degrees before, but we could easily just redefine the value and say temp Celsius equals 15 degrees and run that cell. No problem. The value's been updated, and we could then print out, if we wanted, that temperature in Celsius is now temp underscore Celsius. And what we should expect to see now is when we run this is that we print out, we get temperature in Celsius is now 15.0. And sure enough, when we run that, that's exactly what we see. So what happened that we saw before, and what's mentioned in the warning message here, is that if we try to access a variable that has not yet been defined, we get a name error. We got this with the sign function, the math function, and the square root when we first ran them, because we didn't define anything to give them a name. So if we had, for instance, tried here to print out temp Fahrenheit or whatever and run this, I'm going to get a name error here that says temp Fahrenheit is not defined. Well, if I look back up in my notebook, nowhere earlier have I defined a variable called temp Fahrenheit. I calculated temperature in Fahrenheit here, but I never stored the value as temp Fahrenheit. So as a result, when I run this cell, I get a name error that says, well, we can't do anything with that because you didn't tell me what temp Fahrenheit is. So if instead I went to the cell below here and I said, okay, well, let me define this then. Temp Fahrenheit equals. And we can use our same conversion that we used before. And that is to say that our temp Fahrenheit is equal to, let's go with 9/5 times temp Celsius plus 32, just like we did before. And if I run this, now I can see that I've calculated that value. And if I go back up and run that cell I ran before, now I get temp Fahrenheit equals 59 degrees. It was 10 degrees Celsius that got converted to 50 degrees earlier. Now we got 15 Fahrenheit or 15 Celsius being converted to 59 degrees Fahrenheit. And that looks to be about right. So in this case, what's interesting is that these cells were run in a little bit like not quite sequential order. What the notebook is going to care about is that we've run this cell first, and you can see by the fact that it says 19, it's the 19th code cell that we've run. And then we ran the code cell here to print out the value as the 20th thing that was done. It's not a great idea to do this, to put things out of order like this, because oftentimes people think top to bottom. The code tends to be run top to bottom, but just be aware that there are some cases where if you've run something down below to define a value, that you can then print it in a cell that's earlier on in the notebook, and that the execution order is indicated by the little number inside the parentheses there. And yeah, so that's that. And just as a kind of heads up to pay attention to the order in which the cells are executed, especially when it comes time to the exercises. And when you work on the exercises, sometimes you will have run a cell lower down and then you're modifying something higher up, and you may get unexpected behavior as a result. So just pay attention to that. And if we just want to print out just to see what we have in temp Celsius and temp Fahrenheit, I'll just print these two quickly just to see what the two numbers are. So we can see we have 15 and 59. I'm not writing this out in a very nice way, but you can see those two values, 15 and 59, for our temp Celsius and temp Fahrenheit. And if I copy this, I'll just copy what's here, paste it here, and I'm going to redefine the value of temp Celsius to be equal to 20 degrees, and then print them out once again. When I do this, what you can see is, okay, here's my temp Celsius, 20 degrees, and my temp Fahrenheit is still 59 degrees. So I have used this conversion here before to calculate temp Fahrenheit equals 9/5 times temp Celsius plus 32. That temp Fahrenheit value was stored when I did that calculation. And at that time, temp Celsius was 15 degrees. So just because I changed temp Celsius doesn't mean I changed the value in temp Fahrenheit. So maybe a little bit different, for instance, than like if you had an equation in an Excel spreadsheet, for example. Then usually when you change a value in one cell, it will recalculate automatically in the other cell as well. And here, unless we explicitly went and ran this cell again, the value of temp Fahrenheit would not change. Okay. So that's a little bit of stuff on variables. Maybe I'll just quickly ask, are there any questions at this point before we go to looking at data types? At least when I'm there in person, I'm usually reasonably good at gauging whether there are questions in the audience, but unfortunately, I can't see anything today.
Are there any questions? There are no questions.
Okay, all right. So let's look a little bit at data types, talk about what the kind of idea here is, and explore data types just a little bit. So when you have a variable, or when you have any value in Python, it has also a data type associated with the value. And in Python, there are four basic data types. Of course, there's many others, but there's four basic ones. So one is a type int, int, which is meant for whole integer values or whole numbers, like 4. Then there's float as a data type, which is meant for decimal values. So like here's the first, pi with the first 4 digits of the numbers that follow. str is meant for character strings, and usually those would be indicated by being in parentheses or quotation marks, like hot. And then bool, which is short for Boolean, and those are for true or false type of values. And you can check out what kind of data type you have for a given value or variable value using the type function. So if we made a variable, for instance, called weather forecast, we could assign a value of hot to it. And then if we were to check the type of weather forecast, we could see what kind of variable type the value that weather forecast contains has been stored as. And I think based on what we see above, we would expect to see, for instance, that this would be type str, indicating it's a character string. So when I run this, sure enough, we get back to the data type for weather forecast is indeed str, or a character string. And okay, that's good. That seems to be what we would expect anyway. Now, let's have a look at some of the other things we have. Like, for instance, we could have a look at the type of temp Fahrenheit. Type of temp Fahrenheit, like that. Run that one. I get back that's a float. So it's a decimal value. And if we scroll back up to the place where we've dealt with temp Fahrenheit, we see indeed, wherever we have it, it is 59.0 or something else. Maybe it was, well, yeah. Temp Fahrenheit's always been, I think, 59.0 at the times we've stored it. But we see, of course, that it's type float, indicating it's a decimal value. And what happens if we try to combine the values for temp Fahrenheit and weather forecast, such as by doing this? And I'm just going to copy paste this because I don't feel like typing it in right now. But if we copy paste this in here, so we say temp Fahrenheit equals temp Fahrenheit plus 5 times weather forecast. 5.0 times weather forecast. What happens when we run this? We get a type error. And it says can't multiply sequence by non-int of type float. Probably this doesn't make a great deal of sense to you, but what it's saying here is it's trying to multiply this character string, weather forecast, by a value that is not a whole number, but some kind of decimal value. And what that means is exactly not clear to the computer. This is the way in which it's saying, I don't know really what you're asking me to do. So that then gives you the type error here that says I have 2 data types and they're basically not compatible with each other. Float being multiplied by a string is not a compatible set of data types. If you were to multiply a float by some other number, no problem. But float times character string, and it's just kind of like, what do you want me to do with that? Hence the type error. But it doesn't mean you can't do any math involving character strings. And so the next little thing here for you to do is to take a minute or two just to play with character strings in Python. So maybe you could define a couple variables and make them both character string variables, and then see what happens when you try to add them together. or to subtract them, or to do other math operations involving your character string. So you can use this cell here and just type in two variables that you define as character strings and see what happens when you try to interact with them. And again, just take a minute or two, and then we'll continue after that. Okay, so let's just demonstrate how this works. Let's have maybe a variable that we can call, oh, I don't know, how about first part. And let's say Python is. And second part. These aren't very creative. Sorry about that. And I'll do space. Cool. So if I print out, for instance, first part plus second part, what happens? Well, it turns out that what it will do is it will just concatenate or add together these two strings, just first one, and then right after that, put in the second piece. So you end up with one single string that says Python is cool. Okay, that's kind of nice to know that if you want to add strings together like that, they're perfectly compatible, string plus string, no worries. It also is the case that if you were to do something like 5 times first part, that also works just fine. You get Python is, you can see repeating that thing 5 times, which is a nice thing because, there are some instances where like maybe you want to have a nice, you've got a program that writes something out to the screen and you want to have some nice dividers between the text that's printed to the screen. So you could say, for instance, take this dash and say 80 times dash and print that to the screen, and you get a nice line like that, or whatever character you want to change it and use a star, change it and use a star, no problem. However, of course, if you try to do first part minus second part, adding them together is fine. Subtracting them is not okay because it's not clear what you're trying to do then. Like, there's no clarity about what operation is meant to happen here. When you add two strings together, it's just like, okay, well, take the first one and then add the second part after that. But when you try to subtract them, do you want to remove the word cool from Python is? There is no word cool in that string. What exactly are you trying to do here? Are you trying to subtract things, one by one? It's just ambiguous, and that's the reason that in this case, you get a type error when you try to use the minus sign. You would also get a type error if you tried to multiply two strings together because they're not able to be multiplied. It's just not clear what you're trying to do. And similarly, if you try to divide, you get the same kind of error. So there are some things you can do with math and strings, but there are lots of other cases where it doesn't work. In the data type compatibility, this is part of the reason why you want to be able to check what kind of data you're dealing with. So as mentioned, this is our first little taste of Python. There is an optional part of the lesson here about character input. It doesn't really make a lot of sense to do it in Jupyter Notebook, so I'll leave you to do that if you'd like to, just see how it works. But basically, this is a way in which you can ask the user a question and have them type something in as an answer and then store the value as a variable. But you can find out how to do that on the course webpage. And if you'd like, you can then go in and follow that part of the lesson in the notebook here just to get a little bit of experience. So yeah, that's our taste of Python for today. And we have a little bit of time here still to introduce the exercise for this week. And one other thing, which is our good coding practice. So GCP, good coding practice, number 1, is about selecting good variable names. And good, of course, is in quotation marks. But the point here is that some variable names are better and more useful than others. And for example, if you want to share your code with somebody else, having good variable names is really important. However, even if you're going to take a summer break and come back and look at your code several months after you've written it, you might not know what the variable s actually means and what it stores. So these are some examples of not so good variable names. So s equals some character string, or sid equals some character string. I don't know. It may not be clear to you what what these things are, because these variable names are so short that there's not enough information given there to tell you what the value is that you're storing. And probably you could add a couple characters here and make it look much more intuitive in terms of what value is associated with this s or sid variable name. Of course, if you get carried away with it, you could end up with a variable like this one here. So Finnish Meteorological Institute observation station identification number with no underscores or anything there to break it up. Of course, that is another variable name that is more descriptive, absolutely, but it's not readable because of the way it's been formatted here. And it's frankly also perhaps a bit longer than it needs to be to store this given value. So it's leaving room for improvement. And there are two kind of examples here of ways to format your variable names and some tips for how to select good variable names. The tips here are basically that the variable name should be clear and concise. So it should be long enough that it explains what it's used for, but it should also be not too long so that it's kind of difficult to type in. Unfortunately, the standard is that English should be used for the names of variables when writing programs, especially in languages like Python. When you're sharing your code with other people, it's generally easiest to do so with English as the default for the language for the variable names. It might be appealing, for instance, to choose a variable like muuttuja, but of course, there's other reasons why that's not a very good name, besides the fact that a lot of people who are not Finnish speakers might not recognize what that word is. Of course, calling a variable is also going to be quite confusing. The variables shouldn't contain any special characters, so like lämpötila would not be a good one because of the a and I that are here. So that's going to be something you should also avoid. Kind of stick to the standard ASCII characters in order to ensure that the code that you're using supports the variable name you're defining, and they shouldn't conflict with any kind of reserved keywords. So this could be things like true, false, and, if, else, and for. These are things that have special functions in Python, so you shouldn't use variables that are overwriting those names. In fact, I think you'll probably get some error message if you try to do that. As far as the format goes, there's a couple examples here. So pothole case naming is usually where you have different words and you just separate them by underscores. This is kind of the standard way to do it in Python. So like we've seen temp underscore Celsius. We could have, for instance, FMI underscore station ID for our variable name. That would be much easier to read and still clear what it's meant to convey. But another option would be to use this camel case naming, which you basically then just capitalize each successive word in the name of the variable. So like temp Fahrenheit was an example of that one. We could have also here FMI station ID written like this, or simply station ID written like that. That makes it much easier to read compared to what we had before when it was Finnish Meteorological Institute Weather Observation Station or whatever it was, some ridiculous long thing. So that's the good coding practice for this week. Again, these are just ideas to help that when you're learning code, learning how to do it in a way that makes it easy for people to read, understand, and use the code that you're producing, including yourself in that group of people. All right, so last thing, this week's exercise. Exercise number 1. I don't think it's going to be super heavy in terms of the coding you have to do or anything like that, but there's a couple important things that are part of this week's exercise that we're asking you to do. So first off, the exercise is due in 1 week. So at the beginning of class next week on the 11th of September, First step is to make an account on GitHub. So you go to github.com, click sign up, and put in your information that's needed to create yourself a GitHub account. And if you're prompted or when you're prompted to select a plan, choose the free option. We're not using any kind of paid GitHub services or anything like that in this course. So that's step one of the exercise. Step two, if you haven't joined Discord already, is to join Discord. And once you have joined, go into the week one channel and make a post with your full name, your GitHub username, and the course code that you are in. So either Geoc 3001 or Geog 329-1. So there's a couple examples here. If you're joining from another university, you could then just put in your university name in place of the course code. But yeah, you should go post something in Discord to help us actually mainly in connecting people's names to their GitHub usernames so that we know which GitHub accounts are associated with which people in the course. And then lastly, there's a little bit of Python coding. This involves going here and using our system called GitHub Classroom, which we'll talk a little bit more about next week. But to start the assignment, you click on this link here. Once you have your GitHub account, you should be able to click this, and it'll come up with something that says like this, accept the assignment. So I'll click accept, which is going to make me my own personal copy of the exercise number 1. So anything I change in there will be my modifications, and it will be private so that only myself and the course instructors could see that. So it says you accepted the assignment. We're configuring your repository now. It may take a few minutes to complete. Refresh this page to see updates. So I'm just going to follow the instructions and refresh it. It says I'm ready to go. And it gives me this link I can click on, which is my personal copy. I can see it's called exercise 1-Dave Whip, which is my GitHub username. And now I can look through here and I can see a few things. One of them is we have a pre-course survey that we would like you to fill in. This is an e-form. If you click it, you'll see just a couple questions that come up with your name, email address, and some basic questions. The probably most important part for us is the kind of experience you have with programming and also your availability for working on the exercises. We will pair people up for like exercise 2, 3, and 4 at least to work together with someone else. So it's helpful for us to see, like, if there's absolutely new people, we like to pair them up with people who have a little bit of programming experience to balance things out a little bit. But that said, if you want a partner, you can also put in your partner name that you would request here, and we'll try to pair you up if we can. Can't guarantee it, but we'll try to do that. So please fill in the pre-course survey at the start of that part of the exercise. And then in here, you'll see basically what you're going to do is you're going to make a Jupyter notebook. So create a new notebook, and then you're going to define a couple variables in there, one called ice cream rating and one called sleeping rating. And this has to do with the fact that Finland has been inspired, I guess, the exercise by the fact that Finland's been ranked as the world's happiest country for the 6th year in a row. But we arrogant Geo-Python instructors think we know a better way to assess happiness. So we're going to do it based on ice cream and sleeping. So you define those variables, then you'll define a couple other variables for your first and last name. Do a little bit of math, which is basically to calculate a happiness rating from your ice cream and sleeping ratings. Check some data types, and then print some things out to the screen that look like this. So you'll do that in your notebook, save it, and then you can upload it to GitHub. I guess if I look at it like this, I basically can just add a file and then choose upload files. So if I've downloaded my notebook to my own computer, I could then upload the file that way to my GitHub repository. And please note, you should be in the version of exercise 1 with your GitHub username, not the regular exercise 1 GitHub, because there you won't be able to make any changes. It'll tell you that you don't have permission to upload any files or anything like that. So you have to make sure you're in your exercise 1- and whatever your GitHub username is. But that is I think that's everything for this week. I do understand it was a lot of information, and I'm sorry to have been talking for so much of the time. I don't normally like to do this for the course, but every year the first class is just a lot of like basic getting you up to speed kind of stuff. So yeah, exercise 1 will be due next week before the start of class, and you can complete it by uploading your files to GitHub. Are there any questions or anything before we finish up? I've got one maybe last thing I'll just make note of here. And that is that there are some people who've been having issues with getting enrolled to the course. If you're having problems with Sisu or getting enrolled in the course, please just go to the enrollment issues channel in Slack and post something there so that we can kind of try to keep track of everybody and not accidentally miss anyone who's trying to register for the course. But otherwise, are there any other questions or anything at this point?
No questions here.
Okay. All right, so yeah, we will continue in person next week. I'll try to get the lesson video up at some point today, hopefully. But I'm at a meeting for the whole week, so I'll try to do that as quickly as I can. But normally it should be up within a day or so of the class. And if there are any questions, please feel free to post questions in Discord, and we'll see you folks in person in the same place next week. So bye for now and see you next week.